In life, just like in video games, there are ways to enhance your experience through the use of equations. In this video game, there are a set of rules that you must abide by. Much like how in our world, we have physical laws. These are the laws of physics and they cannot be broken. But if you know enough about these laws, you can predetermine the outcome of a situation. Through the use of a few simple equations, you can get the universe to do your bidding. These are the cheat codes of the universe. I'm Damon and this is Astronomical. Now, if I was to ask you to think of an equation, it's likely that the first one that comes to your head is E equals mc squared. It is by far the most popular equation in all of physics. Now, it might look confusing, but it's actually very simple. It states that the energy of a system is equal to the mass of a body multiplied by the speed of light squared. That's it. And the reason this is so profound is because for so long we've always thought that to have energy, a body must be moving in some way or another. It must have a velocity. But what Einstein discovered was that all matter can be converted into pure energy. And the speed of light is a very big number, even more so when you square it. So what this means is that anything around us, regardless of how small, has a tremendous amount of energy. Let's take this rock for an example. Let's say this weighs 25 grams. Now if we plug that into the equation, that means the energy of this rock is 0.025 kilograms multiplied by 9 times 10 to the power of 16. Which means this rock has enough energy to power the entire United Kingdom for a whole second. Every light, every toaster, kettle, TV, refrigerator, everything that is powered by some form of energy in the United Kingdom could be done so for a whole second by this rock. Now we are yet to figure out a way to do so. We always lose some energy in the form of one process or another. It's always given off in the form of heat or sound. We lose it that way, so we can't convert all of the mass of a body into pure energy. And the possibilities to what we could do with that amount of energy are endless. If you took my mass and converted it into pure energy, then that would be enough to power the entire United Kingdom for almost an entire hour, which is just ridiculous. Equations allow us to figure out the solution to a problem without ever having to go through the physical process. That is why they are deemed the cheat codes of the universe. You can figure out the answer to a question without ever having to lift a finger. A real life example is just behind me. That is Big Ben, one of London's most iconic sites. And right now it's going under refurbishment, which means there is scaffolding surrounding the tower. If I was to go to the top of Big Ben and drop a bouncy ball from its 96-meter peak, how long do you think it'd take for it to reach the ground? Now you could have a variety of guesses at this. You could say it takes 2 seconds, you could say it takes 20 seconds, but you'd never know for sure without going up to the top of it and dropping this ball. Except without the help of an equation. And this one is very simple. So we have h, which equals the height, the point at which you are from the ground, equals half multiplied by g, which is the gravitational force you experience. Throughout the majority of our planet, you will feel 9.81 meters per second squared. It doesn't vary much depending on if you're on Mount Everest or if you're at the lowest point of Earth. And then finally, we have t squared. Now t squared is time multiplied by itself. So we know the height of Big Ben, which is 96 meters. We know the gravitational constant is 9.81 meters per second squared, which means we can figure out the time it takes to reach the ground. The time it takes for this ball to reach the ground dropped from the height of Big Ben is 4.42 seconds. And I've done that without having to climb Big Ben like I was King Kong. It does work both ways though. If you were to go to a tall building and then drop a ball like this, assuming no air resistance, and measure the time it takes to reach the ground, you could calculate the height of that building. But perhaps that equation isn't very useful for you. You might not use it every single day. But there are equations out there that people use all the time and have changed and transformed the way we see our planet. There's one equation that unlocked the seas and allowed us to travel across the ocean. That boat moving across the Thames behind me is only doing so because of one man's brilliance. And his name was Archimedes. And it's because of him we could travel to different continents and conquer our entire planet. That cheat code unlocked the rest of our world. This is a story of the Eureka moment by Archimedes. It all started when the king of Syracuse paid a goldsmith to make him his latest golden crown. But he felt suspicious of the goldsmith. The crown seemed to be lighter than expected. He thought maybe he had snuck in some silver alongside the gold, but there was no way for him to prove that he did. Which is why he then tasked a 22-year-old Archimedes with this problem. Now the problem was, a crown is an irregular shape, which means it's very hard to measure its volume. And Archimedes was under strict instructions that he should not damage the crown in any way. He was puzzled by this challenge, and he was one of the great thinkers of his time. In fact, the solution wouldn't come to him until one day when he was in the bath. See, as Archimedes lowered himself into the bath, he wondered, why does the water trickle out? Now this is something we've probably all noticed ourselves, but his genius was to realise that the amount of water that was displaced was in correlation with the volume of the body added to it. So, if you had an irregular shaped object, like a crown whose volume is very hard to measure, all you have to do is measure the amount of water displaced and you can determine the volume of the object. Then, from that, the density of it, and determine whether or not the goldsmith was in fact cheating. In this moment of brilliance, he was so overcome that he leapt out of the bath and ran through the streets completely naked, screaming, "Eureka, Eureka," which in Greek means, "I got it, I got it." But that's a part of the story we don't need to reenact. Oh. Whoops. Now, if you've ever thought about taking over the universe, there are a few things you need to know beforehand. One of which is the laws that govern the universe. Perhaps the most fundamental is the gravitational law. This was proposed by Isaac Newton in the 17th century, and it states that any two points of mass will have a force of attraction between them, and the sum of which can be calculated by multiplying these two masses and dividing them by the square of the distance between them, and then multiplying all of that by the gravitational constant. Now I know that might sound confusing, but it's not. I know all equations might look confusing because at the end of the day, they are just a couple of letters with some very small numbers nearby. There is rarely any context to them. But I'm going to explain this to you very simply. In fact, I'm not even going to use a pen and paper. Newton's law of universal gravitation was known as the first great unification. It was the first time that anyone had correctly proposed a method that explained the relation between one of the fundamental forces on Earth with the behaviour of other astronomical bodies. The law states that every single particle attracts every other particle in our universe. So there we have it, the law of gravitation. It states that two objects of mass will have an attractive force between them. and the sum of which is their mass multiplied by one another. Mass of the object 1 multiplied by mass of the object 2. And then you divide this by the distance between them squared, or their radius. And then multiply all of that by the gravitational constant. Everything you see around you has an attractive force to one another. I'm attracted to that tree. The larger a body of mass, the more attractive it is. But because of that constant right there, the force we feel is very small, and for good reason. That is the gravitational constant, and it has a value of 6.67 times 10 to the minus 11, which is incredibly small. It's because of this that you and I won't feel any force between us whatsoever. But on a larger scale, between planets and moons and stars, this comes into effect. It's only when we start to venture towards somewhere like a black hole when these laws break down. Everywhere else in the universe, this applies. But if you go somewhere like a black hole, it gets very mysterious. Now, another elegant equation that was explained later on by Newton's law of gravitation was Kepler's third law of planetary motion. It states that the period of a body squared is proportional to the distance it is from the primary body cubed. It's that simple, and it is incredibly elegant. It explained just how far bodies would be from the sun depending on how long their year was. And it led to calculations here on Earth that predicted planets further out in our solar system. Building upon the workings of Kepler's third law was Bode's law, which correctly predicted the orbits of the dwarf planet Ceres and the gas giant Uranus. But what they realised when employing this equation is that they found a gap in between Mars and Jupiter. There should have been another body in between those two planets, but there wasn't. And astronomers searched and searched and searched for centuries in order to find out what was in the gap. And they found the likes of dwarf planets and large asteroids, but nothing that resembled a planet that should exist in the gap. And it wasn't until fairly recently that we realised this was where the asteroid belt was, the remnant of a much larger body. And the reason it no longer existed was because it sat in between Jupiter and the Sun at the right sort of point that meant it could never form a large body. The gravitational tugs of both Jupiter and the Sun meant that it never coalesced to form a planet like Earth, which means we now have millions of bits of debris, just like these pieces of snow flying around my face right now. Great. For me, the first time in my life that I realised the true power of equations was when I was 15. I just finished playing football on a Sunday and decided on getting a 10-inch pizza for dinner like I normally would. But because I was so hungry, I wanted a bit more pizza, and rather than getting a 12-inch, I decided to get two 8-inch pizzas instead, thinking that this would be more pizza. But I was very wrong. So, without thinking, I ordered two of these tiny little pizzas, which you can probably tell isn't quite as large as one 12-inch. But had I have known one very simple equation, I could have solved that without wasting my money. You see, all you have to know is the area of a circle. It's solved by multiplying pi by the radius squared. Now pi is 3.14159265358979323433884197169399328419716939937510. In fact, it goes on infinitely, it goes on forever. But you don't really need to know the time 8 points, you just need to know up to 3.14. In fact, for this comparison, you don't need to know it at all. Next time you go to buy pizza and you want to figure out which one's the best value, all you need to know is the radius. So in this scenario, the radius of the 8-inch is 4 inches. That squared equals 16. The radius of 12-inch is 6. That squared is 36. 2 times 16 is 32 versus 36. There you go. So from that basic bit of math, you can tell that one 12-inch pizza has a larger surface area than two 8 inches. Two of these are £5 each, which means £10, whereas one of these is only £8. Basic bit of maths can save you a lot of money and get you lots of extra pizza. Now this next equation is a real cheat code of the universe. It's something that many of us believe is impossible to do. Something that only exists in science fiction. And that is time travel. But time travel is real, and you and I can both do it. I'm going to show you exactly how to, but first we need to understand a few conditions. We need to understand the laws of time travel. The first is that you can only travel forward in time. The arrow of time flows in one direction. You can't travel back in time, which means sadly for me, I can't travel back 20 years to when Arsenal used to be the best team in England.
Arsenal are the champions!
But what it does mean is I could travel forward 1 year to when Arsenal will once again be the best team in England. This is my twin, Mitch. Now I'm going to be moving very close to the speed of light, which means time for me is going to be ticking faster than it will for him. By the time we return, I will be younger than he is by almost exactly a year. Now I'm going to be standing here still for 365 days, whereas Mitch is going to be traveling very close to the speed of light, the speed limit of our universe. And in doing so, he is going to experience far less time than I will. Now Mitch is going to be moving very close to the speed of light, which is impossible to do so on just 2 feet. But let's just imagine, for the sake of this experiment, that he can move that fast. Here we go. Did we win? No. Oh, it got so much worse. How much worse can it get? You can take it from here. Now the reason Mitch has travelled forward in time is because he was moving very close to the speed of light, which is the speed limit of our universe. Now this equation states that the closer you are to that speed, the faster time moves for you relative to an observer. Now I have been the observer in this experiment, whereas Mitch has been the one moving. It doesn't matter how fast you move, if you have a velocity of any sort, then you are time travelling relative to an observer. Which means every time you go on a walk, a run, if you're in a car, bus, train, an airplane, you are time travelling. The only difference is you are doing it by such a small value that it is almost insignificant. You cannot notice this difference in time. We are talking on a scale of nanoseconds at the very best, which means if you were to be on a train moving at 200 miles per hour for your entire life, you wouldn't age much different to someone who was just sat at home for the entirety of their life. It's only when you go out into space and move at these tremendous speeds that time travel really becomes something that you can feel and notice. The second way to time travel is to be close to a significant body of mass, which we are. We are very close to the Earth, which means we experience a time dilation effect. In fact, if I stand on this, then compared to Mitch, I am experiencing time at a slower rate than he is. It is a very small difference. We are talking about a foot in difference. That's all it is. But time is now ticking faster for me than it is for him because he's closer to a body of mass, a very significant one. It's still on a scale where it is pretty much negligible. You cannot notice the effects of this. But because of this, your head is slightly older than your feet because of the difference. But it's so small, you cannot notice it. But if you go out to somewhere extraordinary in the universe, somewhere very special like a black hole, a place of incredible mass, then the effect of time dilation becomes very apparent to the point where you can practically stop time from your perspective. Now in school, you are taught a lot of equations, and it might seem like most of them, if not all of them, are completely meaningless. It might feel like once you've learned them at school, you know you're never going to use them ever again outside of the classroom. I know I felt the exact same myself, but that's not what's going on. What is happening at school is you are being taught the most essential and fundamental skill in life, and that is how to problem solve. Now the reason I call these the cheat codes of the universe is because they are some of the most fundamental laws in our universe. And most people don't fully understand how they work, but now you do. Now you can explore our cosmos to its deepest depths. The theory for time travel, all the maths around it, is solid. We've solved that part. The only issue missing now is the engineering. We don't currently understand how we can move that close to the speed of light. But maybe you could be the person who solves that problem. Maybe you could be the person who takes us to other solar systems, to other galaxies, to the very end of the universe itself. And you can do so because you now know the cheat codes of our universe. I'm Damon Scotting, and this was Astronomical. How would you like to have your name spaghettified by a black hole in front of thousands of people at the end of every single episode? Well, now's your chance. Astronomical is produced just by me, which means the scripts, recording, editing, social media, and costume design are all done by myself. And after the first 2 seasons, the budget is basically empty, which is why I'm now looking for donations towards the future of this science documentary. And they start at as little as £1. If you want to watch your name be annihilated by a star as it swells into a giant before going supernova, then you can do so for as little as £1. Or, if you'd like to watch your name be ripped apart into its individual atoms by a black hole in a process known as spaghettification, then you can do that for just £5. And then finally, for just £10, you can take your place amongst the stars where you belong, because anyone that donates to science is a superstar. There we are, and if you can't donate at all, that's completely fine. Just make sure you like and subscribe, because that also goes a very long way. Cheers.